My name is Angela, taking this LABMP 590 course. And for my presentation, I'm going to do genetic engineering. Now, you might think, what exactly is genetic engineering? And simply put, it's the modification of an organism by changing its genome. And genome is like an organism's set of instructions. It describes how an organism will act, how to look, how to function. So if we change the genome, we'd be changing the organism itself. And we think that genetic engineering is hard and all, and it sounds complicated, but we've actually been doing this for millennia. We breed individuals together with specific traits we want in hopes that their offspring will also display those traits. So let's take this fruit for example. What do you think this fruit is? Or what it used to be?
Is it a banana?
You're correct.
Pomegranate.
It's a banana.
Okay.
So it's actually a banana. And
Okay.
this is the modern day banana compared to the ancient banana. And as you can see, they look very dissimilar. The ancient one has a thick, unpeelable rind, lots of seed, very little fruit. But then after we've genetically modified it through selective breeding, we get the modern day banana that we know today. Lots of fruit, seedless, easy, thin peel, delicious to eat. What about this fruit? What do you think this is?
Watermelon?
Yes, it is a watermelon. Same as before, we can see a very thick rind before, lots of seed, very little fruit, and I don't think it'll taste as good as today's watermelon.
Yeah.
And it's not just fruit. We've also domesticated animals through this. Take the wolf, one of the top apex predators in the world. Through millennia of genetic engineering and selective breeding, we've managed to come up with man's best friend. And it's not just that. We took it one step further and we further diversified our best friends into a wide range of breeds that display specific traits we want or that we find cute. And we did all this without really knowing how it worked. We just knew that if we bred two individuals together that showed the traits we want, their offspring would also show that trait. And we didn't really know why that was until we discovered DNA. And with DNA, we were able to genetically modify life. We could change an organism by changing its genome itself. We started to inject snippets of DNA into organisms' genomes to modify them, and we got things like insulin, clotting factors, and growth hormones out of it that we didn't have before. We also came up with things such as golden rice, which is rice that has been modified to contain elevated levels of vitamins. And on a more fun side, we came up with glow-in-the-dark fish. So however, genetic engineering at this point still remains very expensive, inaccessible, and time-consuming. And that is until we found out about CRISPR and Cas9. Now, CRISPR and Cas9 are significant in that they drastically reduce the cost, time, and inaccessibility of genetic engineering. So instead of needing a fancy laboratory with lots of fancy equipment and tons of funding, you could do it, any lab could do it. The cost of genetic engineering dropped drastically overnight, and what took years and years to do now only takes weeks. And CRISPR revolutionized genetic engineering. And we talk about CRISPR, but what exactly is CRISPR? We'll have a short video to show you that can hopefully explain things better than I can.
Care, or in a document, if we suspect we've misspelled a word, we can use the find function to highlight the error and correct it or delete it. Within our DNA, that function is taken on by a system called CRISPR-Cas9. CRISPR is short for clustered, regularly interspaced short palindromic repeats. CRISPR consists of two components, the Cas9 protein that can cut DNA and a guide RNA that can recognize the sequence of DNA to be edited. To use CRISPR-Cas9, scientists first identify the sequence of the human genome that's causing a health problem. Then they create a specific guide RNA to recognize that particular stretch of A's, T's, G's, and C's in the DNA. The guide RNA is attached to the DNA cutting enzyme Cas9, and then this complex is introduced to the target cells. It locates the target letter sequence and cuts the DNA. At that point, scientists can then edit the existing genome by either modifying, deleting, or inserting new sequences. It effectively makes CRISPR-Cas9 a cut-and-paste tool for DNA editing. In the future, scientists hope to use CRISPR-Cas9 to develop critical advances in patient care or even cure lifelong inherited diseases.
Alright, so that's what CRISPR is and how it works. And the CRISPR system is fully programmable. You give it a copy of the DNA you want to express, we inject it to an organism, we can turn genes on and off, replace cells, and edit living organisms. So one of the applications of CRISPR currently is that we might be able to use it to cure diseases.
In a document, if we
cure diseases. And there are many diseases we can cure, like for example, HIV. HIV stands for Human Immunodeficiency Virus HIV. It's a virus that attacks your immune cells. And as you can see here, the graphic says there is no cure, but it should actually be saying there is no cure yet. So in a few decades' time, we might be able to cure HIV using CRISPR. And how does that work? Well, so HIV is a retrovirus and it hides inside your DNA. So by modifying CRISPR with those snippets of the HIV virus, our immune cells can find these HIV viruses more effectively and eliminate them. And they actually did a trial in 2015 where they used CRISPR to cut HIV out of living cells. And then a year later, a team in China, they injected CRISPR into the tails of rats who had HIV in all of their cells. And what they found out was that using this treatment, they could eliminate 52% of HIV genes inside the mouse. So that's pretty interesting. And it's not just limited to HIV. Maybe we'd even be able to cure cancer. Yes, cancer. So we can edit our immune cells, give them a copy of the affected cancer cell, and make them better at identifying cancer cells in the body and eliminating them. So the first clinical trials for treating cancer patients with CRISPR was approved in 2016, and I believe it was for the treatment of lung cancer. So in the future, instead of cancer being this deadly disease that required multiple rounds of treatment and radiation, it might just be as simple as getting a vaccine, where scientists take a sample of your DNA, modify it in the lab with CRISPR, and inject it back inside of you. So then in the future, it's no big deal, Mom. It's just cancer. We can also use it to cure genetic diseases. Over 3,000 diseases are caused by a single incorrect letter in your DNA. So what if we build a modified version of Cas9 that can identify the incorrect letter and fix it, effectively curing the disease? And we have many genetic diseases such as colorblindness, Huntington's disease, albinism, and even cystic fibrosis. They range from being mildly inconvenient, such as colorblindness and albinism, which is where you lack color pigments. As a result, you're extremely pale, or can be severely debilitating and even lead to death, such as Huntington's disease or cystic fibrosis. So with genetic engineering, we might be able to cure these diseases. And since a lot of these diseases are heritable, by fixing that incorrect base, we can also ensure that future generations won't inherit this faulty gene. So then that leads us to the problem of designer babies, and we hear a lot about these in the media. So instead of curing diseases, what if we prevented it entirely by screening and editing the genome of an embryo? Well, obviously, we can prevent diseases, and many diseases have a genetic component where your chances of getting the disease are slightly higher if it runs in your family. So we could use CRISPR to identify the faulty sections in an individual's DNA, cut it out, correct it, and thus prevent their future descendants from getting it as well. And it's not just genetic diseases, we can also cure things like maybe Alzheimer's, or certain people have genes that put them at higher risk of things like depression or mental illnesses. So if we can identify those genes, maybe we can make those individuals slightly more resistant to mental illnesses. And then, so as genetic engineering becomes more accessible, cheaper, and more socially accepted, it won't be about time before we start modifying ourselves for vanity traits. If we can genetically modify ourselves to become resistant to all these diseases, why can't we also modify ourselves to become taller, fit to the ideal beauty standards, be a violin prodigy, or even be taller? What's stopping us from that? And is it ethical to modify humans that way? If we do, then in a few hundred years' time, genetic modification would be the norm. And you can argue that by not modifying your children, you'd be putting them at a disadvantage with their peers who are taller, smarter, more muscular. And as it becomes cheaper, there will also be a commercial aspect that comes into it as well. Different companies may start trying to advertise their services, pricing options, different payment plans to genetically modify your children. And this not only raises ethical concerns, but also it widens the social economic gap, as these modifications will most likely only be available to the rich in first world countries. And altering the genome not only impacts the individual changing their genome, but it also impacts their descendants as well. Is it ethical that the decisions your great-great-great-great-grandparents made hundreds of years ago still affect you today? Because the genetic engineering, you're not the only one who feels the impacts, but all your descendants will as well. And genetically modified humans will pass on their modified genes and will forever change the gene pool. Modified humans could soon become the new standard. And this leads us to the biohappiness revolution. And so David Pierce, a transhumanist philosopher, he suggests that all prospective parents worldwide should be offered pre-implantation genetic screening and CRISPR genome editing to pre-select the paid threshold and hedonic range of their future children, and that ideally all babies should be designer babies. So besides correcting genes that may give an individual a higher chance of developing depression, David Pierce suggests that we just eliminate sadness altogether. So then he says this before birth, parents would be able to choose, pre-select kind of the pain or the sadness threshold that their children may be able to feel, and we can kind of put like a cap on it so you can't be sad below a certain level. He also says that genome editing and CRISPR-based synthetic gene drives can extend the biohappiness revolution across to all free living non-human animals, and that free animals should be free from starvation, predation, and other cruelties. So not only should we genetically modify humans, but we should also extend this to wild animals. So happiness is more than the absence of suffering. Even if we do eliminate that sadness gene from humans, we can't guarantee that that's going to make us happy just because we don't have suffering. Happiness has to come from somewhere and in response to something. And his response to this, David's response to this, is is that recalibration doesn't entail buying into anyone else's version of paradise. So what I think he's trying to say is that instead of everyone being happy at the same level all the time, you kind of just set a baseline for it. And that since everyone's happiness, they experience it by themselves, it doesn't have to fit into anyone else's standards of what happiness should be. So happiness doesn't come from an external stimulus, but rather from inside. So what I think he's trying to say. And yeah, so instead of happiness stemming from the absence of suffering, we're just increasing our ability to tolerate these stressful events and become more desensitized to it, not letting us get to us as much. And there's also bliss and unproductivity. Wouldn't a state of constant uniform bliss make us unproductive, accomplish less, do less, not motivate us? And David says yes, but only if it's uniform bliss. He talks about a gradient of bliss. And I think Kim, you made a comment about how you don't really understand how the gradient of bliss would work. So what I think he says is that, again, we set kind of a certain base level of happiness that can fluctuate. So maybe if you're feeling ecstatic all the time, top of the world, nothing much will get done. But if you're feeling pretty good most of the time, when you wake up and you appreciate the small things in life, maybe that's what he's trying to get at, just setting that certain baseline. So he clarifies that only uniform states of bliss will decrease productivity and that the levels of blissfulness can change and vary with information. That can be intensely motivating. And then finally, there's also CRISPR and wild animals. And I'm also kind of dubious on this. And David says that genome editing and CRISPR-based synthetic gene drives can extend the biohappiness revolution across to all living non-humans, and that wild animals should be free from starvation, predation, and other cruelties. And yeah, I think this sounds a bit plausible, because if we genetically modify animals that way, so they won't feel pain or starvation, what's keeping them from eating, finding food, acting like wild animals, and keeping themselves out of danger? Not much. And as you know, if an animal doesn't feel any pain or starvation, it's probably going to die out pretty soon and not be able to pass on its genes to future generations. So I'm kind of doubtful on his plans for that. Yeah, and if we fed wild animals, they didn't have to hunt to keep them out of danger, wouldn't we be essentially domesticating them and changing their behavior? So then in a sense, they'll no longer be wild animals, but they'll be domesticated. And even if we do get to that point, we'd have to design and supervise a natural world. There are thousands of ecosystems out there, and we have to monitor all of them. And I don't think we can do as good as a job as Mother Nature can. Not to mention a world free from predation, but then you have carnivores. So then where are the lions going to get their food from if they're not hunting this ox over here? I mean, I guess David could argue that you give the lions lab-grown meat, but then again, that's not entirely plausible. So this ends my presentation for today in genetic engineering. Thanks for listening, and if you have any questions, feel free to let me know.
So what do you think about the idea that one of the important things that humans do now and have always done is this struggle? We have a struggle, we're striving, we meet resistance to things and we overcome that resistance and so on. And that somehow this idea of editing out all suffering and all predation, so no animals kill other animals. First of all, wouldn't it be, it's such a big project. How would we ever reach, there are humans who have never been contacted by modern humans, right? So-called uncontacted tribes of humans. But if you look at all the animals in the world, how would you ever, make contact with them all to get this genetic alteration? But what I feel is that I'm discovering something here which is quite exciting, which is there must be a student somewhere who could make it a major project of theirs or a life work, to kind of figure this stuff out about what we should be aiming for and what is extreme, what are genetic modifications that we shouldn't make, and sort of define better where we're going, what we're aiming for. So on November 21st, the medical students had a speed dating research thing where 30 faculty like me were there and 90 medical students, and we gave our pitches and so on. And it was kind of interesting. It was at a time where there were a lot of exams and other things, so many of the 90 students who had signed up didn't actually show up. So you ended up with about 30 medical students and 30 faculty. And I was very pleased that a lot of the medical students that I knew came even though they had these pressures of other things. But as of right now, there is no one who has responded to my pitch saying, yes, this is me, I want to do this, I want to define what this future we should be. Yeah, so I'm positing that it should be a young person doing that because they have a much greater stake, right? I mean, we're talking about a huge part of your life that would be influenced by this choice of what we're actually aiming for and how much modification and shaping of nature we're willing to do, right? But it may be that this just does not sound appealing to most normal young people. But it would only take one, right? It just takes one who feels internally, yes, this is what I've been always looking for, But I really haven't found it yet, but I don't think, I can't write the medical students off because they just had a big test last Friday. This is only Tuesdays, they have to sort of get their life back. And then maybe one or more of them will contact me and tell me how much they want to be the person setting this standard for what we're aiming for. So tell me about that, though. My feeling that it should be a young person who suggests that. Do you also feel that way, or are you looking for some wrinkled old person to suggest something to you?
So just like how there are new problems popping up every year and every decade, there will also be new solutions coming up. There will also be people coming up to solutions to those problems. And I think that maybe if the younger generations, since it impacts their life more, they should be more attuned to these problems and more motivated to figure out a way to solve these problems. And maybe they can come up with novel ideas that haven't been proposed before because of advances in technology or new information that they know.
Yeah. No, I think I'm on the right track. It just might take a while. And what I'm saying is, once we identify what this future vision is, then we need graphics, not just one picture, but like multiple pictures to give you an idea what this whole future vision is like. And then wouldn't it be better if the young person also had graphic arts skills and could draw all this stuff and so on? Yeah, so I may find one person who can do-it-all, who thinks that this is what they're destined for, and they would like to put their mark on this particular vision for the future, and they can make the pictures so that people can understand what it is that they think we should be aiming for. And then it would be fine if there were other alternatives too. If other people out there say, well, I looked at what this one person, because in the past, writing about utopias has not worked well. When one person writes a utopian novel, it doesn't seem like a good utopia to other people. So really, what it seems to me is the entity that could create this future vision best would be Chat GPT or something like that can figure out what would be the best compromise that most humans would like, rather than saying, well, this is based on my life experience, this is what I want, right? So I think that is possibly how it might work. It would be a collaboration between, sentient machines, if you will, and humans. But I guess just being practical about it, once we find somebody who's really enthusiastic about doing this, there's an obvious role in the comment section of David Pierce's video then for the young person to go in and say, well, we've been thinking about this and this is what we want to do, and these things aren't acceptable and these things are, and so on. Yeah, so that would be the next step, and to engage in dialogue. So, Ryan, what do you think about?
Yeah, I have a few questions. So, in your personal opinion, do you think it'd be cool to have build a video game character when you have kids?
Oh, I think in theory, it sounds cooler and better than it actually would be in real life, because sometimes, you plan things a certain way, but then it doesn't turn out that way. It might be that way with engineering as well. You might say, oh, I want my kid to be tall, but then once you put the tall gene in your kid, something else might go wrong, like maybe their skin turns green, I don't know. We don't know, no one knows yet. And also, once we do get to that point, people will start treating genetic engineering like it's a game, like you said, it's a video game, without actually thinking of the consequences and how those choices will not only affect your kid, but also your kids' kids, your grandkids, and so forth.
Do you think with the whole idea that David Pierce puts out, do you think there's going to be a homogenization of traits? Like, the best ones will all be everywhere and less diversity because of that?
Yeah, I think to a certain, well, yes and no. I will think there would be less diversity because certain traits are more desired than others universally. Like, who doesn't want their kid to be smart or be a violin prodigy? So then if everyone is smart and everyone's a violin prodigy, you could argue that it does reduce the gene pool. But then at the same time, it might also increase diversity. Because let's say you were genetically born with black hair like me, and now you want to have blonde hair. Well, now you have that option, and by putting that option in, I guess you could say you're increasing the gene pool a bit.
Okay, that's a very good answer.
Yeah, so you can imagine that there would be rules and laws about what you can do, right? And maybe some countries, some societies would have laws and others wouldn't. And so people who wanted to do something really extreme, make their body like 30 feet tall or something, there would be countries where you could do that, but most countries you couldn't engage in really extreme modifications. But I think all the other things that I discussed, it all happened so fast. So like the Bletchley Park AI safety meeting was November 1st and 2nd. And then just a week later, Rich Sutton and I talked together, and he had these ideas of like an automatic world where nobody's in charge, but it's optimized for what humans want and need in theory, but it just naturally happens, right? He thought that would be better than a world with somebody in charge or something in charge. But then if you wanted something changed, there'd be nobody to talk to, right? So in a way that seems like more of a bad outcome than good. And then there's the, designed future as opposed to a biologically determined future. And it just seems like we'd be missing something if we weren't passing on our genes anymore, if things were determined by, design principles rather than our own genetics. But maybe that's just my 2023 bias, and people of the future will feel quite different about that. So it will be interesting to see what happens, whether somebody does step forward and identify this as a really interesting thing that they want to do, or in a month or two from now, I'm still looking for some young person who wants to help me make these suggested future visions. Okay, well, I think that's good.